Welcome to my talk. Today I'm talking about giving you an overview of UI testing with Compose. If you've done some Compose already, maybe you haven't written any UI tests. Today's a good chance to learn about how to write some UI tests for the Compose code that you've been writing. My name is Michael Bailey. You can find me on Twitter at YogurtEarl. I'm a distinguished engineer at American Express. And we are hiring, so please check out our website for the job openings that we have, or come talk to me afterwards. Oops. All right, so just a brief review of a couple of concepts of types of tests that you might see in Android projects. One type of test is an instrumentation test, and that test is code that is compiled into an APK, loaded onto a device or a virtual device or an emulator, and then executed in the process of your device, of your application on the device. And that's mostly what we're going to be talking about today. There's a few other types of tests that you can run just on a JVM on your local machine or on your CI, Roboelectric tests. There's a few examples of Compose with Roboelectric in the Jet News app. And a lot of the stuff that I'm talking about here today works very similarly when you're running the Compose test rule in Roboelectric tests. You can also create multi-platform applications, and then in theory, put some tests in the common modules, although in the default examples that they generate when you create a project in IntelliJ, it doesn't work out of the box, but there's placeholders there, so presumably that will be an option soon. And you can see here how you can create a Compose multi-platform application, and it gives you source sets for common code, source sets for Android, source sets for desktop. And so if you were able to write your tests in the common area, you'd be able to run them under the desktop target. And then you can use things like Paparazzi to run Compose and take screenshots of it as well. The last talk was about Paparazzi, so go catch the recording of that talk or check out the website there. If you want an overall view of how Android X tests work, I gave a talk previously about the details of that and all the options that are available within Android X test. But today we're talking about, okay, you've got some Compose UI that you've written in your application, and now you want to write some unit tests for your Compose UI. How do you do that? The first thing you need to do is add the right dependencies to your application. So there's one dependency that brings in the JUnit rules called UI test JUnit 4. You add that to your Android test implementation configuration in your Gradle project. That will add that dependency and the classes in that dependency to your test APK if you're doing an application module. And then there's another thing that you add here, a UI test manifest dependency, and you add this in your debug implementation, which actually puts it in the app under test. And this doesn't contain any code, but what this does contain is a manifest that gets merged into your app under test. And this is, if we can see, we're looking at the AAR for this dependency. You can see there's nothing under classes. There are no classes in this dependency, but it does have a manifest. And that manifest adds a component activity that gets merged into your app APK so that the Compose test rule can start up an empty activity to inject some Compose into, and then it operates on that. If you're testing composables in sort of a standalone mode and you don't have your own activity that those composables are added to. So make sure to add that to your debug implementation. All right, so let's look at a test rule. So this is the first thing you need to do is add a Compose test rule. And this is a method that comes with the JUnit dependency that we looked at before. You have to make sure to add @get rule. This is the annotation that tells JUnit to run this rule as part of your test. If you forget that, you'll get strange runtime errors with the rest of the code that you have here because it didn't actually execute it as a rule for setup. Then with the Compose test rule, you can use set content to test just a bit of standalone Compose UI. You put it in the set content block, and it will inject that into an activity. Like we saw before, it creates an activity, puts it in there for you, and then you can do various assertions and actions on that. And down here we see what we use again, the compose test rule. There's extension methods on that that allow you to find nodes. So these are finder methods. We're using onNode here, which tries to find exactly one node. There's also all nodes, which finds a collection of nodes, or there's onRoot, which grabs the root of your composition. And then once you have found something, you do either perform an action on it, like perform a click, or you assert something about those node or nodes that you have found. So that's the general form of the assertion, the action and assertion part of your tests. If you've written espresso tests, which are targeted at testing your Android view system UI, you'll be familiar with onView type methods that espresso gives you. Here, you notice it's onNode. And so what is that node that it's talking about? Well, in this hierarchy, compose is just functions, and so there's no views to grab onto. And so there's this parallel tree that it creates with, you have your composition, and in parallel, it creates a semantic tree, which is a tree of nodes that is both used for accessibility, and it's also used for testing. And so by thinking about and understanding and building a mental model of the semantic tree, it'll help you with both making your app more accessible, but it would also help you debugging and understanding why tests may not be doing what you want. So we're going to talk a bit here about how to build up the model of the semantic tree and how that affects how you grab onto things for tests. So just to give you an idea of what this very simple UI here is, we have a button. It says click me. It increments a count that's a mutable state. And then that click count will get incremented. And I've also got the same code running in an activity just so we can look what it looks like in an emulator. So it's just this very simple UI that we're doing. And then I've got that same code directly in the test. And if I run the test, you'll see that it pops up very quickly and increments the count. And then by clicking on it here, and then it asserts that the count was actually 1. And you'll see we'll get the green checkbox down here, and this test passed. So the next thing you could do, if you already have some composable in an activity, rather than saying create compose rule, you would say create activity, Android compose rule, and as a generic parameter, you give it the rules showcase activity, which is where that code was. Then you can just delete this code altogether, and it's just going to test whatever composables are in that activity, and it launches that activity. So we can run this test again, and now it's running the code that's in the activity, but it's going to run the same click, and it's going to do the same assertion. You can see it also passes there. So if you want to just have a bit of compose UI, you want to test standalone, you can just use set content with the compose rule. If you want to test your full activity and all the compose that's in there, you can use create compose Android compose rule. Let's go back to what we had. Okay. You might notice that this gets a little bit verbose, and it's a little bit different than Espresso in that all of these methods that you're calling on Node are all extension methods on compose test rule. And so we have a bit of repetition in bigger tests. You're repeating compose test rule a lot. So one thing you can do is just use a with statement to bring this into context as your the this, and then you can remove all the explicit calls to compose test rule. And we can rerun the test. And now we don't have to repeat that within the test. We see test pass. There's actually a newer option that it came in one of the latest Compose release that for certain scenarios allows you to just eliminate having to do this rule setup at all, and you can just run compose UI test. And this is guarded by the experimental test API flag, so you need to opt into that. But this will do all the setup of the rule for you and inject it and give you the reference as the this within the block that you execute. So you can get rid of that rule stuff, and for at least most simple tests, you can just run it like this. You can see the same test runs and passes. All right, so what is it that we're operating on? Let's take a bit more look and understand a bit more about the semantic tree that's in play here. So we'll bring up the activity, which has the same code in it. Launch that in the emulator. Then we're going to pull up the layout inspector, which will attach to our UI. Zoom in here. And this helps you inspect what's in your UI so that you can write the right matchers and finders to find the right things and perform the actions and the assertions there. So at first pass, we look at this and we see a bunch of stuff that's not reflected in our source code. And this is because this is all the details and implementation details of how button is implemented within Compose. And so we might want to filter this out to better understand it. So there's a few things up here you can do. You can highlight the semantic layers, and these are the composables that have some semantics attached to them. And you can see, in this case, it's mostly just the stuff that we've defined that has some semantics attached to it, and all this other stuff gets grayed out. And you wouldn't want to use that stuff in your tests anyway, because it's implementation details that can change over time between Compose versions. So you can also just filter out the system-defined layers, and then you get a very simple view of the stuff that reflects within your source code. And if you click on it once, you'll see it gets highlighted in the layout inspector. If you click on it twice, it highlights that composable in the source code. So it can help you map back to what you're seeing in the component tree at runtime to what you're seeing in your source code and help build that model. Now, if we look over here on the right-hand side, and we scroll all the way to the bottom, we'll see a thing that says declared semantics. And so each node that's been highlighted here, all the nodes except for column, which is grayed out because we have this highlight semantics layers, all of these have semantics attached except for column, and that's why it's grayed out. So the text has two things in its semantics. And a semantics is a strongly typed key value map. And one of the things that you'll see in here is text. And we can see the click me button that corresponds to the text in that text. And there's two things you need to be aware, two types of semantic trees. One is the unmerged semantic tree, which just sort of has the raw, or here it's called declared semantics. And everything in that tree is attached directly to the node that it was declared in. So the text is attached to the text, and so on. And then there's another tree called the merged semantic tree, where parents can merge up all of the values of their descendants and attach them to the parent node. And this generally will happen for things that are clickable and focusable. So if we look at button, we will see that button has declared semantics, and these are things that are directly attached to button in the semantics tree, that node, the button node. But it also has merged semantics. And these merged semantics, you'll notice, contain click me. So because this text is a descendant of a node in the semantics tree that merges its descendants, it will have its text put on the button. And so when we do this, the test code here, when we do onNode with text, click me, the node that it's finding in this case, because we're looking at the merge tree, is actually the button node. It's not, in this case, finding the text node. Now you can set the flag to look at the unmerged tree, in which case, and it would actually work either way in this case, but it would the node that it would find is the text node if you look at the unmerged tree. But that's important to have a mental model of which node is being returned, whether using the merged tree or the unmerged tree. If we look down at this text node, it actually has its own merged semantics. So if you look at declared semantics and merged semantics for this text node, which is the click count down here, they're actually the same. And that is because it doesn't have a parent somewhere in the hierarchy in the semantic tree that is merging up the descendants. So it keeps its own semantics in the merged tree. So the second line on node is actually finding the text node in the semantics tree. This first one is finding the button node in the semantics tree. So that's one way to inspect it. If you have an application and you can just bring up a certain screen and connect the layout inspector, that's one way to sort of dig into what the semantics are and better understand. Another thing you might want to do is if you want to see the semantic tree at different points in your test to try to understand my matchers aren't working or something's not quite doing what I expect, you can add some logging statements. So if you use the finder on root, which finds the root of the semantic tree, then you can do print to log. And by default, on root, we'll grab the merged tree. So we can print this as merged. And then we can also pass in a value. Most things in the Compose test UI or Compose test API take a value of use unmerged tree, which allow you to do the unmerged version of it. So we can print both of those, the merged and the unmerged. And then we can run this test. And we can pull up logcat. And we can scroll all the way to the bottom. And we can see here we've got merged over here because that's the tag I gave it, and then unmerged. And so you get a better visual representation of this tree structure. In the unmerged case, you can see that the text kept its own click me, and button doesn't have any text at all in the unmerged tree. And in the merged tree, you see that that whole text node is just gone. There is no text node under button. We just have the button, but the button includes the text that was merged up to the parent in that case, and that's the merged tree. And by default, everything operates on the merged tree unless you explicitly say that you want to use the unmerged tree. Now, one thing that is a bit confusing and maybe could trip you up as you're starting to write some of these tests is the way that the key value pairs work, especially for text. So let's say that we change this a little bit, duplicate that. What if we put the click and the me into two different text composables? If we run it, it's going to look the same. Looks the same in the UI. We'll do the same thing over here in the test. But now if we run this test, you see the test fails now. Even though the UI looks the same, and we're trying to grab a node with that text, and it's actually grabbing the button node, which is the merge of all the merged parent in the semantics tree, but it's saying it's looking for exactly one node, because when you do on node, it's always looking for exactly one node. If you're trying to find more than one, you would use all node on all nodes. But it couldn't satisfy that the text is click me. Okay. So if we go and look at the logcat again and see what we can use our debugging statements to maybe help us out here. Scroll down to the bottom. We could see in the unmerged tree we have two different things. We have click and me as two separate nodes. But here we have button and we have click me. But if you notice, there's a comma here. And what happens is the text is a list. It's a list of annotated strings. And what this is doing is it's going, it's looking for each thing in that list and saying, does it match? And it says, does click match click me? No. And does me match click me? No. And so it didn't find any nodes. So in this case, you could do a couple things. You could adjust the semantics on your UI, and usually you want the semantics to make sense for the accessibility APIs. So you want to design semantics in that way, and then you want to write your tests according to those. So sometimes it's good to massage the semantics to make them work better with accessibility. Other times you may be using a composable you don't have direct control over, so you can't really change the semantics. Or you might have other reasons why you don't want to or can't change the semantics. So the other alternative is to write different finders to still find this even in this structure. So let's take a look at how you might write a custom finder. So you would write an extension function on semantics node interactions provider, which is an interface implemented by the Compose test rule. And then you would give it a name, use the naming pattern of on node. We'll do on node with joined text. We'll look for some text, which is a string. And we will return a semantics node interaction. Okay. So the we can use the built-in on node, which is just a more generic finder method that takes a semantics matcher, and then we can write a semantics matcher that does what we want here and matches on this type of node. So we give it a nice name so it would print out nicely. All right, so this then iterates over each node in the tree, and it will give us a handle on the node and give us an opportunity to say yes or no. This matches or it doesn't match. And in this case, because we're just trying to match one, it's trying to find exactly one. So on the node that it gives us, that key value store that has all the semantics is called config here. So first we're going to look at config, and then we need to look it up by the key. And it might not be there on some nodes, so we want to say get or null. And then we're going to use text, because that's the key that we're looking at. And notice that, and we're going to join it to string. But if you notice the text here, and this is kind of the crux of the problem, it returns that list of annotated strings. And we're just trying to find one string. So what we can do is we can join all of those things in the list. And then we've got to map, they're annotated strings, so we've got to map them back to strings by doing it.text. And now we have the concatenation of all of those things in the list, and we can just compare it to the text that was passed into the finder method here at the top. So now if we've written a custom matcher, we passed it into onNode to change the logic of how we find things, and so now we can use that up here on node with join text. And even though we have click and me in separate things that get merged up into a list at the button level, we can run this test. It'll run, and you can see now it does find that. And so when you can't massage the semantics to make them more meaningful, sometimes you have to write custom matchers to be able to find the thing in the tree. And having that model of like, what is the semantic tree, what's the merged tree, what's the unmerged tree, can really help you understand when it's not able to find things and what type of custom matchers that you might need to write in this case. So another interesting thing that you could run into, and again where this mental model would help, is if I had an on node with join text. And this is probably not something that you'd write, but if I wanted to assert that the text contains click, which is kind of an odd thing to assert because we're finding something that says click me, and then we're asserting that the text contains click, and we're actually just going to move this back to the way it was. And run this, you think that while it might not be a super meaningful assertion, you'd think it would work and pass. But it fails, and so that's where you sort of think, okay, what's the semantic tree here? What am I missing? Why would that? I've just found some text and then asserted that it contained the word click, and it looks like it would contain the word click. Well, let's look at the message that it gives here. It gives an assertion error. We have text click me. Assert to find the following that the text contains click. Well, it kind of looks like the text contains click. But what's actually happening here, and maybe this could be named a little bit better, is it's actually checking for exact string matches on everything in the list. So when it says contains, it's not saying that the string contains or the text contains. It's actually saying the list contains this exact string. And so it's checking click me versus click as the first thing in the list, and so that doesn't match, and it goes to the next thing in the list, and it's the only thing in the list, and then it says, well, I couldn't find anything that matches exactly. So in this case, you have to know, and if you read the documentation there, it does mention in the document that it's checking the list of text items in there, and the contains is, does this list contain this thing? There is an option in here to say substring equals true, and so if we do that, now it goes through the list still and sees the list contains things, but it does a substring match on everything in the list. And now the test passes again. So let's take a little bit of a turn here and talk about animations. So I've got an activity here similar to what we had before. But instead of just adding 1, we add 5, and we animate that as state over 5 seconds. So it counts 1 every 5 seconds. So how would you test something like that? So we've got the same code here, just injecting it directly into the test so we can keep it up on screen here and see what we're testing. Again, it just adds 5 to the count. It's an animate into state, so it takes 5 seconds, and with a duration of 5 seconds, so 1 second per thing. Well, by default, when you call these methods on node and perform, it automatically advances the clock as far as it can, sort of in real time. But if you have now you probably wouldn't have a 20-second animation, but if you have a longer animation, you don't want to have play that animation out in all your tests, because then your test will be slow. So what you can do is you can control the clock, and this is a method, main clock is a method on the compose test rule. By default, auto advance is true, meaning the clock goes forward. But you can set it to false, meaning that as soon as we add 5, the state has changed, but the animation is basically paused until we tell it to advance to a certain time. So let's say we want to specifically look at the state of the UI 4 seconds in. So we're advancing the time, basically skipping directly instantaneously forward to 4 seconds and 17 milliseconds, which is 4 seconds plus 1 frame, so that it should say total equals 4. And if we run that, we'll see that it flashes up. It goes directly from 0 to 4 really quickly, and then completes successfully, and the test passes. Almost so quick you can't even see it. So that way you're testing at this exact point in there, and then if you could advance it to another point in the animation if you wanted to test a separate point in the animation. You can also use a similar setup to capture images with this and then compare them against reference images. This is what the animation is supposed to look like at certain points in the animation to make sure that when you're changing things, nothing breaks. You could grab the root of your composition, you capture that to an image, it returns a bitmap image. That is a composed bitmap image. You call as Android bitmap to turn it into a native Android framework type bitmap. And then the Android X-Test Compose API, or just the Android X-Test, actually give you a method that writes it to storage that handles the various storage weirdness across APIs, so it can do it somewhat consistently across different API versions. And it'll write it there. So if we look now in the device file explorer, I'll delete this one that I had there. So we've got nothing in the test files, so it's SD card, Google test output files is sort of the default place where it puts stuff. And at that, as we've paused it right here at 4 seconds, we're now going to say, grab the whole thing and write it out to an image before then asserting that the text is this. Now in this case, it's just text, so maybe taking an image isn't as meaningful, but if it's something more visual where it's hard to, and you want colors and other things that are visual in nature, then taking a snapshot and comparing it to a reference snapshot. If you intend to update it, you can update the reference snapshot, but if not, you can just write it to storage like that. So let's run this test. See, it'll come up in the API. Fast forward it to 4 seconds in. It's going to take a snapshot, save it to the device storage. So let's look back on device here. Now I'm going to hit a refresh here. And there we've got the total 4.pmg, which is the name we gave it. And it's taken an image at that particular point in the animation when it was stopped with a total of 4. And so you can reliably compare certain parts of your animation to reference images. All right. So idling resources. In espresso tests, you may have written idling resources. When Espresso is operating on your UI and you need to tell Espresso, hey, wait until this thing in my app is finished, by default, Espresso tries to go as quick as it can. So it means it might click a button before it's there, or the data hasn't come and rendered fully on the screen, and so it tries to assert data on the screen that's not quite there yet. If you wrap things in idling resources through Espresso, it tells Espresso to wait just long enough until everything's settled down and idle in your application. Compose has its own idling resource interface. By default, Compose will also wait for all of your Espresso idling resources. So you don't need to, if you have a set of Espresso idling resources, you don't need to write another set of Compose idling resources, because Compose will wait for that. If you are not using Espresso at all in your application, and you're doing basically Compose only, that's when you would use the Compose version of the idling resource. So that way you don't have to pull in Espresso or reference Espresso to be able to do the equivalent thing. And it's a similar API to what Espresso has. So if you still have views in your app, you're still testing with Espresso, just stick with Espresso idling resources for now, because they'll work with both Espresso and Compose. If eventually you're done with views and you're completely on Compose, then you can move them over to Compose idling resources. All right, so another thing I wanted to show you is the Compose test cheat sheet here. So this is the test cheat sheet that's available on developer.android.com, specific to Compose. And so while we talked about just very briefly what a finder is, what an assertion is, and what a matcher, there's a lot more that the API offers, but it all follows the same general pattern of you really need to understand what's the merge tree, what's the unmerged tree, and which one am I operating on. And most of them, the methods have a Boolean where you can choose one or the other. Then you either run a single node finder, which are these ones, or you run a collection finder, which finds a collection of nodes in the tree. Then once you have that, and you can use these matchers that are built in. So you can, like we did, we built a custom matcher, but there may be a matcher that's in there already, and you don't have to do the custom logic like we did. And you can just pass the match cert directly into onNode. Once you have a node, you can either assert something on it, or you can perform an action on it. So we saw, like we asserted that it was displayed, but there's a lot of other things that you can assert about once you've found some nodes. And then, or you can perform an action on it. We performed a click on the button, but you can perform all sorts of other actions depending on the type of UI that it is. And then some more about the Compose test rule stuff, and then we also used the print to log statement. And then each one of these is actually, it is a PDF, but oops, it won't reload. Each one of those things is clickable and takes you to the API documentation. So it's a great point to see an overview of all of the things that are there to help you match. And thank you. That's all I had today. A reminder that we're hiring, so please check out our careers, check out the test cheat sheet, check out the Compose testing documentation. There's a whole document on semantics, and if you haven't done the testing code lab, I highly recommend that as well. If you have questions, I'll be around the conference, or you can come up here and I'll answer questions to the side. So, thank you.